Hi there, Mr. Sutton here, bringing you this Pre-Cal Honors 9-1 Extra Practice Number 1 solutions on finite intuitive limits. On this problem, we're told that f is this function right here, and we want to know which of these equations expresses the idea that f of x can be made arbitrarily close to 2 by taking an x that's sufficiently close to 0 but not equal to 0. So we're talking about the idea of a limit here. If we write this out kind of in English, we're saying as x approaches 0, f of x is approaching 2. So to write that out symbolically, we would say that the limit as x approaches 0 of f of x equals 2, which is going to be answer choice C. For this one, the function f has the property that as x get closer and closer to 4, values of f of x get closer and closer to 7. Which statement must be true? So basically we're talking about limits. We're saying as x approaches 4, f of x approaches 7. So to write that symbolically, we would say that the limit as x approaches 4, written like this, of f of x is going to equal whatever f of x is approaching. It's going to equal 7. So that's going to be answer choice C. D had it backwards. D was saying as we get closer to 7, f of x gets closer to 4. And A and B were talking about function values, but remember, limits and function values not necessarily the same thing. Limits are all about what you're approaching. Function values are about what the function actually equals when you get to your destination. On this problem, they're telling us that if the limit of some function at x equals 1 is 3, which of these graphs represents that situation? So taking a look at choice A, as we approach x equals 1 from the left, we're going to 2 for the y value, but from the right we're going to 3. Since those don't match up at all, that limit doesn't even exist. Now choice B, from the left and the right, we're approaching the y value 2, so that at least equals a number, but it's the wrong number. We wanted 3, not 2. For choice C, as we approach from the left and the right, that's going to the y value 3, so that actually works out. But let's take a look at choice D. From the left and the right, this one's going to 1, so that's the wrong number again. So then it would be choice C. For this problem, we're given the graph of f, and we're trying to figure out which of these expressions here has a value of 2. So going through them one at a time, choice A, f of 3, well, that's the actual y value when x equals 3. That's this solid dot right here. That's 4. That's not 2, so it's not choice A. On to choice B. This is the left side limit as x approaches 3. So as we approach the x value 3 from the left side, like so, we're heading towards this value of 2, which is kind of what we're looking for here. So choice B is looking pretty good, but let's look at the other ones. Choice C, this is the right side limit at 3. So as we approach from the right side here, we're approaching the y value 6, so that's not what we wanted. And then the two-sided limit at 3, well, the left and the right-sided limits are different, so that one doesn't actually even exist. So definitely then choice B. For this problem, given the graph of f, we want the limit as x approaches 5 of f of x. So we always have to look at the two-sided limit when we're doing these. So as we approach 5 from the left side limit, we're approaching the y value 2. And as we approach 5 from the right side, this way, we're approaching the y value 4. The left and the right-sided limits don't match up. That means that the two-sided limit, which is what they're asking about here, does not exist, so that would be choice D. On this one, we have a table giving different values of f at selected x values. Based on the table, we want to know which of these conclusions might be supported. So these are all talking about the limit as we approach x equals 4, except for choice D here, which is talking about the limit as we approach 6 from the right side. Since this table doesn't tell us anything about values near 6, choice D can definitely be eliminated right off the bat because we know nothing about the x value 6. So looking at what's happening at 4, as we approach 4 from the left side, so these values that are getting closer and closer to 4 from below 4, looking at the y values, we're going 5 to negative 25, then we're skipping to 125 to negative 625. So there definitely doesn't seem to be a limit as we approach from the left side. So I would call that DNE. Now, as we approach 4 from the right side, So coming at these values like 4.1, 4.01, getting closer and closer, it looks like the y values are getting closer and closer to 6. So we could say that the limit, at least based on what we see in the table here, has a value of 6 as x approaches 4 from the right side. Now, since the left and the right-sided limits do not appear to be approaching the same thing, we would say the two-sided limit does not exist. So that tackles all the other remaining answer choices. Taking a look at all of them, it looks like only choice C has something that's true based off of what we wrote here. So C it is. For this problem, we have a table of values for the function f, and we want to know which of these statements here, based off the table, has to be true. So taking a look at these values, it looks like as we approach 1 from the left side, and they're talking all about what happens as we approach 1, so that's what we're looking at here. As we approach the x value 1 from the left side, these numbers appear to be getting closer and closer to 7. As we approach 1 from the right side, these y values here also appear to be getting closer and closer to 7. So it sure looks like the limit as x approaches 1 of f of x is going to be 7. But now they said which of the following statements must be true. And we don't know for sure without seeing a graph or a formula whether the limit actually is 7. It looks like it. It could be 7, but definitely can't tell that it is 7 for sure. So although answer choice B is tempting, we don't have enough information to actually pick it. A table is never going to be enough information to know for sure. Now, we definitely can't pick choice A either. I mean, the function value is 2 for sure. F of 1 is 2, but the limit could be completely different from the function value. And then there's choice C, that the limit does not exist. Well, it could be 7, so we can't say this one for sure either. So choice D cannot be definitively determined is the best answer on this one. For this problem, we are given the graphs of f and g, and we want to find the value of the limit as x approaches 4, f of x plus 7 over g of x. So when you're doing one of these limit of a quotient kind of deals, you can take the limit of the numerator and the denominator separately. And when you're taking the limit of more than one thing, you can take the limits of each term separately. So we basically need to know the limit as x approaches 4 of the f function before we can answer anything else. So taking a look at my graph, as x approaches 4 on the f function from the left and the right side, we are approaching the y value 3. So we can write then 3 plus 7 for that numerator. Now looking at the g function, as x approaches 4 from the left and right on the g function, from the left and the right, we're both approaching, from both sides we are approaching or y equals 5. So we can do g of x, replace that with 5. And then 3 plus 7 over 5, that's 10 over 5, which just comes out to 2, which is choice C. On this problem, we're given a table of values for the function f at different x values. Based on the data in the table, we want to know which of the following could not possibly be the graph of f on the interval from 1.9 to 2.1. So looking at this table, there's definitely a pattern they want us to pick up on. As we approach 2, which they're not showing in here, but as we approach 2, get closer and closer from the left and the right sides for x values, you'll notice that the y values are both kind of heading toward the y value 3. So based on the table, the limit as x approaches 2 of f of x appears to be 3. So we should have a graph that reflects that. Taking a look at our graphs, choice A, the limit is definitely 3 as x approaches 2. Same thing in choice B. Same thing in choice C, although the function value is different. Where the graph is approaching itself is still going to be at 3. The only graph that's the odd one out on this is choice D. We are approaching 3 from the left side, but from the right side limit as x approaches 2 is actually 4, so the overall limit does not exist. Certainly this is the least consistent with what the table is showing us, which is that our limit appears to be 3. So we're going to go with choice D. Out of all of them, that is the worst possible option.